Hello everyone, welcome back. So now we're finally into chapter 2 and we're going into conservation laws now. So where did we come from? Well, last we were focusing on how we make sure that our flows are similar. So let me say, I've got a scale model, I have a real plane. Are they experiencing the same things? Well, by matching my Mach number and Reynolds number, I make sure that they are. The question then is, well, that's great for experiments, but what do I do if I don't have a wind tunnel? So the next part of this course, we're really focusing in on the theoretical aspects, how we can really look at our equations and build up, the simulations that we need to figure out what happens when I don't have a wind tunnel, or when I can't just test it with a scale model. As a note, anything we develop in this course will not be nearly as advanced as what you see here, but we're building the basic building blocks that then get turned into this kind of code. How do we do that? Well, by developing some really big equations, the conservation laws, in fact. And I just want to say, do not overthink these equations, okay? They may look really complex when you have their full forms, but some things you need to remember. One, we never use the full forms of the equations. Unless you're making your own incredible CFD code, you will never use the full form of the CFD equations. Second thing, conservation laws are just bookkeeping. I'm saying, okay, how much mass is going in, how much mass is going out? How much momentum is going in, how much momentum is going out? Energy in, energy out. It's just a fancy way of bookkeeping. And as long as you think about it that way, you're going to have an easier time. And remember, once again, we're just going to simplify these equations. If we're going to use them, we're going to simplify them with some really important assumptions. Okay, so what conservation laws are we going to run into? Well, there's a few. First off, mass, which this is not the conservation law, this is just the basic equations. It's simply saying if I have a difference between how much mass is flowing into my system and out of my system, well, then the amount of mass in my system has to change. The amount of mass inside my control volume has to change. It'll go up or go down. Momentum, that's just helping us connect all of our pressures and our changes in velocity and our density changes to helping us realize that if my momentum changes, there's a force causing that. It can come from a bunch of different places, but this is all it is. And finally, energy, back to thermo 1. For my flow, if I add heat or I do work on it, it's going to change the internal energy. So how much will you actually use these equations for this semester? Energy, pretty much never. You'll use that all the time, like every single day in Aero 2. Aero 1, we really rarely use it. Mass, it's super, super important. You'll use it a ton. And momentum, you're going to use it all the time. Now, will I use the full form? No. I'm just going to be using things that are 1, simplified versions of these equations, and then 2, I'm going to be using things I build out of them. So they're super, super important, but you're never going to see the full form. So when you get to those big equations later, do not freak out. Okay, so that's it for this time. Thank you all for listening, and next time we'll get into the conservation of mass. Bye-bye.